Okay. Good morning. Okay. In the morning, we are going to, we probably need to, we have 40 slides today. We will try our best to finish in the morning. And in the afternoon, I will go over the midterm exam solution and meanwhile give you the papers. Okay, you can take a look at how I grade. Don't think too much, okay? If your midterm is already done, okay? And let's focus on the remaining of the course and make sure after class you practice every examples I wrote in the class. Try your best. When I say important, that means you have to overly work on that important notes. It's gonna be in the exam, okay? If I say not important, then not in the exam, no need to take care of that. Another thing is probably after. No, I'm thinking about a good time to give you the project intro because I can do it. It's because you have to use all the knowledges till here in order to do, except you two guys. Okay, you are ready after the rest. Okay, then I will introduce your project. But now you can think about what's your group. Okay, what's your group? Maximum 3.
Can be extended for 4.
No, you cannot. Only 3. 3 is maximum. If you have more than 3, that means some student won't have any task to do. Okay. Maximum 3. You can choose 4. You can divide by 2 group. Okay, 2, 2. Okay, let's take a look at Node.js intro. First, why do we need to have a node? Okay, node, the problem node solve is related to the I/O. I/O stands for input and output. What is input and output? You can think any communication between CPU and any other process external to the CPU, like a memory or disk or network. They are input and output. And there's a big issue on input and output is a latency. Okay, so it defines simply a time it takes to complete a single I/O. So here is a general general ideas, okay, which is suppose from one CPU cycle is in actual latency, which is computer time, okay, like nanoseconds. But a scaled to latency is scaled to human time. And it probably 1 second, it can complete one CPU cycle for the human, okay? And the others. Now let's take a look at the extreme one, okay? Suppose we are trying to make a call from San Francisco to New York City. The actual latency is 65 million seconds. But in terms to the human time, okay, you are think like 5 years. So actually it's a huge latency. And think about we have a cross country like from San Francisco to Hong Kong. Its actual latency is 141 million seconds. It's general, okay. And in a human time, it's gonna be 11 years. So we need to have a better way to handle I/Os because it takes a lot of time on I/O, especially you make the internet calls, okay. So I will need to be done differently. There are 2 scenarios in the real world, which we are also, you can compare with the I/O to be done. One is suppose we are going to watch a movie. What's gonna happen is we don't think about buy the ticket online, okay, or use the electric ticket, okay. We go to the booth to buy the ticket, and we cannot get one until everybody in front of us to get one, right? And that also the same applies to the people queued behind you. Also, there's one problem is because when you go to get a ticket, okay, you have say, okay, which one I want to have, and you also need to wait for the cashier to print the ticket for you, and all people behind you have to also wait for printing time. That is called a kind of like a idle time, okay, and all completely wasted. And this is a movie ticket, which means you cannot get a ticket before the one in front of you, all the people in front of you. This is called the synchronous, one by one can handle. How can I make, suppose I have long queues, how can I make it faster? Suppose we have 100 people and everyone take 1 minute and the total is going to be 100 minutes, right? And suppose you have a long queue in Walmart to cash, okay, to check out. How can we make it faster? Which open more, right? That's called the threads. Java is on threads, okay? If one thread cannot do things, we open more threads, okay? That's in the real world. But we do have another one. Suppose we are going to a restaurant to, we go to McDonald's to order the food, okay? You order the food, do you wait in front of cashier to wait your food is ready? No, okay. Other people can also order their food. We don't need to wait for our food to be cooked and served before they can order, right? So the cashier, okay, after you place the order, okay, go somewhere, wait, and I will take care of others. And this is asynchronously. And someone in the kitchen, they will continuously cooking and serving, and other people, the cashier will taking the orders. So people will get their food served as soon as cooked. What's gonna happen is after food is ready, ding, ding, the order number. I'm ready, come and pick up. Okay, that is called asynchronously. Okay, like this is done inside the node. When you have a request to me, I will take care. Okay, your request is received. But suppose I want to get a collection of users. When can I get the collection of users? You have to wait for my signal. Okay, my food is ready. Oh, your data is ready. Then you come back to do your stuff. Okay. So two things. I/O can also be done in these two ways. Like this is the Java way, which is using threads, multi-threads, and JavaScript, which is using this way, which is asynchronously. We'll take a look at. So Node.js architecture it's gonna use a single-threaded event loop advantages. Okay, single thread, which means inside Node from the developer view, we think it only has one thread, but behind thing it has multiple. Okay. What's gonna happen is suppose I have a client comes. This is all the client come to my Node.js application, my server side. What's gonna happen? The thing which will handle your request is from this event loop. So it will continue accept the user's request comes, but it doesn't handle immediately because if I handle, I have to fetch from database, do all things, all other requests probably need to wait. What's gonna happen? It's gonna put in an event queue. Okay, and there are other tasks will get the things from event queue to take care for like handle the connect to database, do all the things. Okay. And when it's ready, it'll go back to your event, it'll go back to the queue, which your data is ready, and then event loop will send the things back, okay, one by one. But basically here, this event loop will take care of all your requests. So no matter how many requests it comes, I just taking the order, I just take it, okay? But I don't actually give you the data back. You have to wait for me. When I'm ready, I'll give you back, okay? And there are something behind the thing, okay? It do have the multi-thread parts, and which is provided by libuv. It means, but from a developer view, we don't think it has the threads, okay, multi-threads. We only consider about event loop part. And another thing, which can also block the event loop, which is a node, is what? When your request comes to our server side, right? Event loop will identify is your code is the asynchronous API or synchronous API. What it will consider as synchronous API? Suppose you have a math calculation. Okay, you want to count from 1 to 1 million. This is a math. And by doing that, the event loop will calculate. It won't delegate it to like other event queue those. It won't, okay, because that's asynchronous. So if we use IO and which we are do like a heavy computation tasks, don't use a node. Node is not like a final. It's what's the thing? Node is not the only solution for do all the websites. And if you have a heavy computation, use Java is better than Node, because heavy computation, it means you're gonna block the event loop, this part. Because if it's the computation, it won't delegate it to other like thread here. Okay, it will do in the event loop, it's gonna block. And what kind of task is better for Node.js is that I/O. Suppose you have a request from San Francisco to other websites, those I/O. And if you have a request which is heavy on file systems, that's better suitable for the Node.js. Okay, if computation, use Java is better. So even though Node.js application receive more and more concurrent client requests, there's no need of creating more and more threads because of event loop. Okay, event loop, it's like think as a McDonald's cashier. Just take the request. Okay. Node.js actually will use less threads. It will use less one resource or memories. Okay, it do have, and we don't go details. Okay, if you want to go to very deep, go to what's MWA course. MWA course will cover again. Node.js is a runtime built on Chrome V8 JavaScript engine. Is Node.js a new language? Not, okay. Node.js, when we write Node.js application, still use JavaScript. Node.js just provide you a platform, okay? Lots of APIs which you can build the server-side program, okay? It is still we still use JavaScript. And the Node.js is built on top of, it has a V8 engine, but not only V8 engine inside the Node. We will see another slide later. Node.js essentially is to build, to create the server-side JavaScript, which is one thing. So far, all the JavaScript code we learned, we cannot do what? We cannot work with our file system. Suppose we use JavaScript code to write some data to the file system. With the code we wrote so far, we cannot do. But Node.js we can do because they have APIs for us to do. We will learn today again. And allow scripts to do I/O in JavaScript. This one talking about, suppose you go to MWA, okay? You will learn how to use Node to read the data from a database. For this course, we don't cover database, okay? In MWA, you will cover MongoDB. If the professor didn't change, okay, which document.
It's not good for dealing with relational database or just for NoSQL.
You can do both. Node have APIs to do relational. Node also have API to do non-SQL database. Okay, it's the same as Spring Boot or Spring the data that API from that API. It can also do with relational. It can also do with non-SQL. Basically, if we have the it will support both, okay. And NoSQL database, it also have many kinds. It have 4 types, like graph, document, column based. It has also many. But for that course, probably only teach MongoDB one, okay. Node.js is event-driven. You will see later. It's like JavaScript is actually event-driven. When we click some buttons, we'll do something, okay? We'll see. And Node is also event-driven. Why? Because here, event loop, when they receive a request, right? I'll return, but the actual response is not the first time I return. What's going to happen is when the go to database, oh, my data is ready. You have to have a signal, which means my data is ready, okay? So it's event-driven. And non-blocking I/O, we'll take a look at later, okay? It's a single thread. And by default, Node.js is a common JS module system, okay? We will see. JavaScript also have its own module system called import exports. I didn't introduce. When we have time, we can take a look at it a little bit, okay? Node.js is using CommonJS, and CommonJS comes before the JavaScript module system, okay? How to set up a Node? Okay. Everyone already download the Node installed, right? Click till next. Okay. After you install Node, you can check the version you are using. Node-v. Take a look at the version you are using. Okay. Let's demo a little bit. Okay. Like Node-v. You will see the version we are using. Okay. And this one talking about. Let me see. Oh. No. Do you remember JavaScript? Java, when you guys learn Java has a shell, which can execute your Java code, right? Node also have a shell. But Node has a name called Node repo. Let's see. Okay. You type Node, it's going to go to the similar place like a Java shell. Okay. And here you can execute the JavaScript code. Suppose I have 1 + 2, 3. Okay. I have 5 greater than 4. You have 2. This is a shell. Okay. And these 2 lines is related. Like you can how to exit from a shell, Control-C twice or Control-D. Control-D. Okay. Shell is normally you want to use it, but if you have some quick test, you can use the shell to test, but it's not friendly to use. Suppose you have multiple lines, it's difficult to use. Okay. This is the GitHub. If you want to contribute your work to the node, if you find, okay, I have a very fancy features I should add on the node, right? Then you can work on that using, okay. Pull request, you guys, it's in Git, okay. You didn't learn, okay. Node versions, it has 2. Let's go to the node. See here, when you go to node, you have 2 versions. One is LTS, the other one is current. Okay, what does it mean? Current means under active development. They are continuing adding features, okay, do all the changes. Code for the current release is in the branch of its major version, okay, something, okay. Node kind of like release new major version every 6 months, and it will allow for breaking changes. Suppose breaking changes is what? You in your code, you use on API, suppose called filter. And then after 6 months, they release another version. The filter does not support it anymore. So this is called the breaking changes, or the feature for the filter into different versions are different. Okay, so this will happen something like April or October every 6 months. Okay, release approach like has support for 8 months. Release well each October. Basically, what it means for production, don't use current because they may have breaking changes. And they don't support very long. So if this version has a problem, and it only support for 8 months for you, okay? And for our production, we want something to be stable, right? So choose long-term support. Like receive long-term support, okay? Which will focus for stability and security. It release every 18 months. So if you have breaking changes, you still have more 1.5 years to fix, okay, your code, okay. We'll have further 12 months for maintenance. So the guarantee is mostly for stability, okay. So you won't have problems on the production. This one is too fast. Every six months, too fast, okay, for us. But for this course, anyone is fine, okay. We just use the basic features when using that fancy features. So anyone is fine. You choose whatever you want. Program, the first one, okay. I do not think this one I need to explain, okay, but we have first demo.js. Yeah. Format, I don't do anything good. I just put it here. This set amount in Node is same as what we learned, but we will see the difference later. Okay, it's actually a little bit different. And set timeout, when we talk about before mid-game, set timeout is provided by the browser, because it's asynchronous API. And set timeout here, we will see another library later. Okay, and when we do, we will see hello and world, right? See this one. When I Node, how to execute Node. I put it here. No. Sorry, I should have put it here. Okay. When we execute this piece of code, I should see no hello and a word, right? Because this is asynchronous, we have to execute a synchronous code first. So we'll say node first. We'll say hello, and after 2 seconds, we'll say node, right? Okay, so all the JS files you can execute using node, some.js, we already covered, okay? Now, node also have a global environment in window, okay? In the browser, the code, we have a window object, right? Which are global, okay? When you define a variable, we use var or function. It's gonna be inside the window, right? And in Node, we do have a global, lots of global modules and methods you can automatically use in any JS code, or any Node.js code, like a module we'll see. And this global, okay? This global is same as a window inside the node. This one global is same as inside the window. See here. Yeah. Did I declare global this variable anywhere? No. And when we execute, you will see something being printed. See here. And this is a global object which exists in every Node.js code. Okay. When we execute it using Node, then you will get it. But if you don't execute it using Node, you cannot get it. Okay. And the same thing like for like a module, like others. Like a module, this is a module. Yeah, I bet. This is our module. We'll see module later. Okay, that's module. This global, and all the things listed here you can use without declare. Okay, because it's a global inside the node, and don't use this one because we will see later. Because Node.js is designed to keep everything locally. Okay, and unless you are sure what you're doing, generally you won't using this object, global object, to attach some global variables. We'll take a look at one by one later, all of them, except this one. All others we'll take a look at. Global scope in Node. Browser JavaScript by default put everything in the window. If we define a variable, if we define use var, or if we define a function, it's gonna put it in window. Node.js was designed to behave differently, with everything being local by default. We will see in a minute what does this one mean. Okay, everything being local by default. Okay. In case we need to set something globally, there's a global object that it can be accessed by all the modules, but not recommended to do that. You rarely will see a case you will use this, you will attach something in the global object in Node. Okay. The document object. This document, do you remember I had some demo before, which is document.getElementID? Okay, when I teach you guys about set interval. Okay. It's also in some DOM. It doesn't exist in Node. Okay, it's like a window. Document, history, location, those don't exist in Node because they are all related to the browser. Right?
What is DOM? DOM.
We'll see here. Okay, we'll see here. Don't worry, we'll see in here. Yeah, haven't it covered. So now, what's inside the Node? This is a node system. Okay, let me open this one. So, I forgot to add my version. Okay, so here, this is your application. Okay, which I write some Node.js file. Okay, I write some JS file and which has some JavaScript code there. And all our code is still running in V8. V8 is JavaScript engine to execute our code. Okay. Ask you guys a question. With the JavaScript APIs we learned, we don't have APIs to deal with operating system, which is write some files into system, read the database, right? and JavaScript don't support that. And how Node can do it? And the Node is doing something using this thing called binding. Ask you another question. Does Java has libraries to deal with the operating system, which are file systems, those things? Yes. Okay. And also the same thing inside where inside the C. Node probably is written in C or C++, one of them. Okay. C or C++ also has APIs deal with the file systems, read the database, those things. Okay. But JavaScript don't have, right? So how Node achieve that? Yes, he using something called the binding, which is a wrapper around the library written in one language and expose the library to the code written in another language. So code written in different language can communicate. Sorry, wait me for a second. I forgot to what happened. What that this one talking about? I have one more here. What that this one talking about? This is our JS code, and this is our operating system, and here have a file system, the thing, right? And have a database, okay, DB this side. So the problem is JS don't have APIs to do that. Okay, and JavaScript don't support because JavaScript was designed to build client-side application. Client-side means a browser. It's not designed to deal with operating system. Okay, so we have a bridge here. So how Node cross the boundary, which is Node will have what's thing. First, the Node is written in C or C++. Probably C++. I forgot. C++. Okay. C++. C++ has API to deal with file system, right? So first, Node.js will use C++ to write APIs to deal with file system and database. But we write code is using JavaScript language, right? So here JavaScript cannot talk with C++, right? So Node will expose all the APIs written in C++ using JS. He will have a wrapper on that. So he will have all the wrapper on using JavaScript, have a wrapper on all the APIs with the C++. So when we deal with JS APIs, and JS APIs will eventually convert with the C++ APIs. And that is called the binding, okay, which are a wrapper on all the library you written in one language and exposed in another language. Okay. Understand me? If you don't understand, forget about it. Okay. Not in the exam. Basically, it's what I'm doing. Okay. Well, C++ has, but JS don't have. So Node is wrap all the APIs using wrap all the C++ APIs using JS. Okay. So then when we write a code, we can use JS to write the code. No need to deal with the C++. Okay. And another one that is this binding do. Okay. That also make the Node achieve can write a server-side APIs. That is this binding do. Did you have a libuv, which is this part? Later on, we will see the event loop, which is event queue inside the Node. You will see it's completely different from what we covered inside the browser. Browser is simpler, and the Node is very complicated. But similar ideas, and that are all provided by another library called libuv. Libuv is also open source project. You can download the libuv and use in your project. Okay, and Node also use that. They do have other like low-level components, like if you want to do HTTP parser, OpenSSL, zlib, the things, Node also have those APIs, and they were written in C or C++, and Node just have a wrapper on that to expose in JavaScript. Okay, and Node also have lots of built-in APIs, which we will see like a file system, others. Okay, we'll see in a minute. Basically, you just need to use it. Okay. JavaScript on server side, like is similar to the slides we draw in the Chrome, but different. Okay. This part is same. Inside the JavaScript on the server side, which is a node, it's a part of node, not a complete node. Okay, we haven't covered. We'll go details later. In V8, we do have a heap. Heap is to store all your objects. Okay, objects will have properties, will have methods. Okay, and other than that, don't put. Like when we have statements. Okay, statement is when we execute in the stack, then it's gonna be happen. And stack to execute the functions. And here, the asynchronous part provided by Node is called the libuv. The asynchronous part provided by window, like a browser. Okay, suppose we have client-side script, JavaScript. The asynchronous part is provided by web APIs. Basically, it's browser or other third library. In Node is using libuv. Okay, so here, when we have a request comes, if a request is asking for is asynchronous APIs, like go to a database, go to the network, go read the files, all of them will deal with operating system, right? And that is libuv provided. Okay, go to the operating system, and when the data is ready, when the operating system is ready, they will go have an event, and your callback gonna be put in event queue. Here we have one queue here, right? We'll go details later. Okay, it's gonna have 8 or 6, 6 or 8 queues. Okay, we'll see one by one. And event loop will do exactly the same as we do. If in the stack is empty, okay, except the global one, no more others, then the event loop will check. Oh, if the stack is empty. If it's empty, I will push the callbacks in the queue to the stack to execute. The scenario is same. The difference is here. It's a libuv. It's not a web APIs. Okay, libuv can also make a request to the operating system. Browser cannot do. And another one is a queue here. We will talk about focus on the queue. Let's take a look at it. Okay, first, what is event loop? This one is from the Node.js official document, like allows Node.js to perform non-blocking I/O operations, despite the JavaScript is single-threaded. JavaScript is single-threaded, but the libuv is not, and the event loop is in a libuv. Okay, by offloading operation to the system kernel whenever possible. Okay, I like this one better. What is event loop? A loop that picks events from event queue and push their callbacks to callback stack to execute when stack is empty. Okay. Even though Node is using a single thread, at least from our developer view, okay, but actually Node use many threads through libuv. Now let's take a look at the event loop. Okay, what's gonna happen? We have 1, 2, 3, 4, 5, 6, and have 8, 9. Inside the node, you have 8 queues. That's the only difference between that's the difference between window and the node. Okay, in window we only talk about 2 queues, right? And besides that 2 queues, in node it has another 8 queues, 6 queues. So first, the timers. This phase executed callback scheduled with a set timeout and a set interval. We do have another. Let's take a look at it here. So the first one is called in Node.js. Okay. We have first the queue. All the rectangle I put here is queues. What's inside the queues? Callbacks. You got me? Callbacks. Okay. And the first one is called a timer. This one is a timer queue. No, let me do like this way. Timer queue. What kind of callbacks should I put in timer queues? When we use API, set a timeout, set an interval. Here I will have a callback, right? This is my callback, right? Whenever in Node you set timeout, set an interval, and you have callbacks, it's gonna be pushed here. Queue, okay? Next one. Pending callbacks. Or called IO callbacks, okay? Execute IO callbacks deferred from to the next loop iteration. This one I'm talking about what? Later on we will see APIs, okay? IO queue, okay? Or callback queue, okay? Doesn't matter. And what kind of callback I can put it here? Today, later on, you will learn APIs to deal with a file system, like a file system dot read. Suppose we do read, okay? It's gonna have a callback, and this callback gonna be put here, okay? And we will see later. Read or write those files. We'll see later. And idle prepare, which this one is used only used internally, which you're not gonna use it. We don't, as a developer, you cannot deal anything with that. Okay. Idle some callbacks internally. Okay. You cannot do anything for that. Okay. Next one, pull. Do you remember when we talk about when we receive a request from the client side? When we receive a request from client side, when we use Node to do a web application, right? And that all those kind is gonna be go to this pool, okay? All the request pool, like incoming connections. Like I have a request to my server side. I have a data like things, okay? Some pool. And here we are also the pool queue, okay? Like this one is like a connection. I have a new connect. There's a new user make a request to my website connections. It's gonna go to this one, okay? The callbacks. And check. Set immediate. This set immediate doesn't exist inside the browser. Browser doesn't have set immediate. Browser only have a set timeout, set interval, clear timeout, clear interval. And this set immediate is in Node, and this gonna be add another queue called check queue. I'll put it here, okay? This one is called a check queue. And this queue is for put the what thing? Set immediate. And we'll demo later, okay? And this function gonna be put here. Okay. And last one is gonna be the close. Close callbacks. Suppose we have a socket close. Suppose what's gonna happen is in this example is I started my server. Okay, I start my server. Server eventually will use socket. If you don't understand, fine. Okay, you can take a look at by yourself later. Suppose I open. I start a server. Later on, I close the server, right? Then this when you attach event on the close that event, the callback gonna be pushed into the close callbacks. That's another example. Suppose I open a file. Later on, I close this file, right? That event also scheduled on close callbacks, which are all the close events. Like suppose later on, I have a file system can register the close like a socket. We'll take a look at demo later if we have time, okay? And those are put here. So far, that is explained about all the queues, which uniquely in Node. It do have other queues for what? Do you remember we talk about we didn't talk about. When we talk about a set event, set a timeout, set interval, I say we have two queues, right? One is for on-click events, set timeout, set interval, those. There's another for promise async await. I said we'll cover later. And also that queue also exists here, okay? But all the queues you see here is inside the node, doesn't exist in browser, okay? So now let's take a look at, wait for a second, okay? Oh, do you have, okay. No, I haven't finished, okay? So what are those lines here? See here? What are those lines here? The lines you're talking about how, so what's gonna happen? You see some lines like this way. Okay, what does this mean? Cycle, okay. Exactly cycle. So ideally, okay, ideally, when we execute our code, right? So we have so many, I have so many callbacks. You got me? Suppose for all the queues, I have callbacks. Which one should I execute first? Should I start from here? Should I start from here? Should I start executing one? Should I execute this one, right? So node have to decide. I have so many queues. Which one should I start, right? You got me? Okay. So ideally, not ideally. Node gonna do what? Node will always start with a timer queue. Okay. Node will always start with a timer queue, and he will execute all the things in the not all the things. He will execute first. He will check when you start a program, right? He will check, do I have callbacks in the timer queue? If it has, it will execute. Okay, and then it will move to IO callbacks. Execute. If I have, I will execute. Then we'll go to the idle, and then we'll go to pull, then go to check, then go to close, and then go back to the timer. So in one tick or one cycle, okay, in one cycle, it will follow the order first, second, then, like this way. But suppose in the callback queue, suppose in a timer, I have 1 million. I have a recursive, I have 1 million callbacks inside the timer queue. Will node execute all the 1 million? No. Okay, node will choose, it will have some set, it will have internally it have some numbers there. Okay, if you have 1 million, I don't execute 1 million here and then continue, because you're gonna have a block. You got me? You only start here, all other queues like for the IOs, for all the connections gonna be blocked. He will only execute probably 100. This one is I guess, okay. I didn't look at API, how many, okay. Will execute 100 out of 1 million. Then I will move to here, to here, to here, to here. So on next cycle, I will execute the remaining 100. The next cycle, I will execute the remaining. Understand me? Okay. Any question here so far? Okay. Basically, just execute it one by start from this one, 2, 3, 4, 5, 6. Okay. Now we have one slide. We will have more slide demo. Okay. Set timeout. Set in immediate. Okay. We'll schedule set timeout exactly same. Okay. But the callback function gonna be in timer phase, and for set immediate, you are schedule callback run after at the check phase of the event loop after IO events callbacks. Let's demo a little bit. Okay. Suppose I have a set timeout, I have a callback function. And I don't do anything, okay? If I don't do anything, gonna be 0, right? And I have a set immediate. DR, this one. Sometimes I still spell wrong. Set immediate, okay. They also have callback. And don't have like a timer. You have something time on that, okay. Now when we execute, you will see, see here immediate timeout. Okay, it's sometimes timeout immediate. See here. If we use our theory, it will always go to timer to here. Then our set immediately is here, right? It should always go to timer, then go to the check phase, right? But if you see our result, sometimes you have immediate first, sometimes you have timeout first. The reason is because what? The reason is because when we execute our program, the node have to do some preparation. So when node get into this loop, okay, get into this cycle, this timeout callback is not registered in the callback queue yet. You got me? Because we push into a stack, right? Then we have to wait somewhere and then push into a queue, right? So when the node, if the operating system, some is very fast, okay? When the node goes to this timer queue, this callback is not in the queue yet. So that's why you see immediate first, okay? We don't go this extreme case because sometimes you see immediate, sometimes you see timeout, okay? But ideally, we will say, okay, we'll have timeout first, we'll have a check phase second. We can do a demo, which is like this one, which can guarantee immediately gonna be executed after a timer. We can guarantee.
Cycle starts once the queues have some callbacks, right?
No, the timer starts when a Node.js code starts.
I'm asking this particular cycle. It starts only when there is a callback, right? So otherwise there is no need for this cycle.
Well, a single loop is always there. When you start, the queues are there, but it
always looking.
Yes.
Okay.
It always looking. Okay, and not it will have what thing. Do I have this event loop? You're always checking. Do I have callbacks? So it's the queues are reserved there. Just don't have any callback if you don't have. Okay, but the queue is there. Okay. We can guarantee. How can we guarantee? The timer will always execute before the check phase. Oh, sorry. Oh, no. How can, so see here. Sometimes I immediately, sometimes I time out first, right? Even though I change, let me change, switch the order. We can only guarantee one, not the other one. Okay, immediate. You. This one is the extreme case. Okay. Okay. Anyway, I cannot go. You can run like 100 times. You will see. Okay. There's one way to guarantee immediate always executed before timer. Yes, here. Do you see here? I have IO callback here. Suppose here. Yeah, I have to explain more. Okay. Suppose we have a file system.read. I have to use others. In the letter. Suppose here, I will explain this one later. Okay. See here. Where's my callback? Oh, here's my callback. Take a look at guys here. This is my read file. Read file gonna be located in the IO callbacks. Okay. In the IO, that means this is my callback function. Okay. This is my callback. This callback function will executed in this way. Okay. In this one. So if I put my code inside here, so no matter my set timeout is before or after it, you will see always immediately gonna be go first, then the timeout. The reason is because your callback is here, right? It will always go to the check phase first, then go to a timer. Okay. So if you want to have guaranteed, you can do like this way. Okay. But otherwise, it's not a guarantee which one gonna be executed, because sometimes you have lots of applications which is open in your operating system, gonna be slower. Sometimes you are fast. Okay. So cannot guarantee. Let's continue on. Sorry. We'll talk about this one. Just now, all the all these queues, right, are actually provided by a library called the libuv. All the queues here called the libuv, which is the library included inside Node. Node do provide their own API called the process.nextTick. And the process.nextTick is not a part of event loop. It will add callbacks into the next tick queue. So besides all the callbacks provided by libuv, we do have another callback for the. We do have another callback between them, okay, called the next tick queue. Okay, and this callback queue is Node.js API. All others is libuv APIs actually, okay. And the node will process all the callbacks in the next queue after the current operation commits before the event loop continues, which means it will run before any additional IO events or timers fired in the subsequent ticks of the event loop. Let's take a look at it here. Okay. So this is my timer. This is IO pulling, okay, and the immediate queue, closer queue, right? So we talk about when the node start a node application, it's gonna start a loop, gonna start from timer one by one, right? So what is the next queue? The next queue is here, okay? This promise we'll talk about later, which is we'll cover here, these two, okay? Next, first, in one cycle, for all the callbacks in close, immediate IO or timer, you only get one chance to execute. One cycle, you only get one chance, but it's different from process and execute. So what's gonna happen? After our timer, right? Suppose here, this is my callback, right? After your timer, it will execute, it will check, do I have any callbacks in execute? If it has, it will execute. And after IO, it will check, do I have anything in my next queue? If yes, I'll execute. If no, I'll return to the call. And then after the idle, do I have any queues in next queue? If yes, I'll execute. After pull, do I have any queues here? If yes, I'll execute. After immediate, I will check, do I have? If yes, I will execute. After close, do I have? If yes, I will execute. So the difference is in one cycle, for all the callbacks in next queue, you will get a multiple chance to execute one cycle. This is the difference. Got me? In one cycle, for all the queues here, you only get one chance, right? But for the callbacks in the next queue, one cycle, you will get a multiple chance to execute. Because after every callback queues, you will check, do I have? After this one, do I check? After this one, check. Do you get it? Okay. And this is one difference, okay? Second difference is what? Do you remember the thing I talked about? If I have 1 million calls, he will only execute a part of them, right? Won't drain all the callbacks in the timer and other queues. But next queue, if you have 1 million, he will finish 1 million calls, 1 million callbacks, which means what? The next queue is completely drained on each pass of event loop before any additional IO is processed. As a result, if we have recursive setting, next queue callbacks will block any IO from happening, just like a while true loop. Don't do that, okay? Because if you have 1 million callbacks in here, he will finish all of them, then continue others. It's gonna block the IO event loop. That is what I'm talking about. Any question here? They designed like that. Because they designed think if I use process analytic, I will give a higher priority. If you don't like it, don't use it. They designed to have you know, if you design your application, you can choose which way you go, right? And the Node.js design process analytic to have this feature because some people may need to have this feature. They have a highest priority. Okay, and if you don't like it, don't use it. Okay. Because I cannot explain more because that's how they design this API. Okay, then you may have cases I want to have this one executed immediately. You know, then you can use process analytic. They have another one which is promise and async await. We'll explain later. And process and promise and async await also have a higher priority compared with others. And you also it will also drain the thing. Okay, async await. Let's take a look at one example of this one. We'll have a next tick. Okay. Process is a global module. Okay, you can use in any JS code. And you just give a callback function. We can copy this to here. We cannot guarantee this two, but Node will guarantee this one. Okay. You can see. Okay, and if we switch the order, yeah, no. You can try as many as you want. Okay, generally it should guarantee this one gonna be executed first. Okay, but probably in some extreme case, depends on the you can try in a very slow computer and see if the result are gonna be different. Okay, but generally guideline is this is gonna execute it first. Okay.
Then the other order of the immediate and the time
we can
change, right?
we cannot guarantee, but generally by this case gonna happen.
This is going to be the same.
Yes, the reason is because what?
This is going to
This is going to execute first. Why is it executing here, right? The timeout already registered here. Okay, so that is the case. Don't worry. Okay, this piece of code not in the exam because we cannot guarantee. Okay, I want to give question like I give you timeout, immediate process, and stick, and what's output. But generally, we have to using this guideline to say what's going to happen in Node. That is one. Okay, I'll report. Okay, let's take. Do you have questions on this one? If not, we take a 10 minutes break and we come back for the modules.
三个有区别。一个是一起是一个，一个是一个。他们不一定，找他了，就随机是吧？跟上面这两边是一起。的话就是他是发的对，这个例子里面。其实他在心里面，然后他们最重要的是。理解他的画面帅吧。哦。
Okay, guys, let's continue. The following lecture going to be in the exam, okay? The following lecture going to be in the exam, and the above not in the exam. So you have to understand well. Modules in JS. We can consider modules as JavaScript libraries. Libraries suppose what can you do in when we do browser, like we have HTML, we have a script, we script some .js file, right? Then that JS file you can consider as a library, okay? And in these modules, we will have a set of functions. Functions you can think also as APIs you can include in your application. Node.js by default uses CommonJS modules, and you can also use the JavaScript ES6 and modules. I can show a demo in the future, okay? But you have to do some extra configurations in order to do that. CommonJS modules are defined in a normal JS file. Use module.exports. And here's another thing. In Node.js, every file is treated as a separate module. So suppose you have several .js file, every JS file will treat as a module. How can we connect them, the JS files? Because when we use Node, we just node some .js file, right? That's our starting point, right? If I have multiple, how can we connect? We use a module system. How you do it? We'll have more demos here. Just have a very simple one, okay? You're gonna using require another modules in that. Okay, we'll see how to do it. First, inside the node, we have 3 types of modules. First one is built-in modules. Built-in modules was the modules which Node provide to us. You already see one, which is process. Okay, process on the next tick, right? Process is a module. We do have other modules which are also buffer. Process is a global object. Sorry, okay. Not a module. Okay. Process is a global object. We have some other built-in modules. We will see buffer. We will see file system. Later on, we will use our Node to create a server. We will see HTTP, and we will use, suppose in a file system, we have to read a particular file, right? We will use a path, okay? That's all the modules which are built in. We do have a third-party modules. We will see later on. Suppose we are trying to build a server-side application, and we don't want to use the HTTP module which is provided by Node because it's very tedious to do. We will see tomorrow, okay? And then we will use Express. Express we will download. It's gonna be a global it's gonna be a third-party module, and we will learn about others. Suppose later on we will solve about a cross-origin, that cross-origin thing, and we will install other modules called CORS. Okay. And we also want to deal with a JSON, and we can download a JSON modules to do, okay? So they also have lots of modules, and if you need, you just go to the website and you can search for any modules. Suppose I want to deal with CORS, okay? And then you can choose them. And those modules are not built in Node.js, which means when you install Node.js, this CORS, this module is not there. You have to download, you have to install, and those are considered as third-party modules. So any modules you download from here, they are third-party modules. It do have last one is your own module. What it means, you create a normal JS file, and it's gonna be a module. Okay, that's your module. 3 modules. And how to use those modules is going to be different. That's why we customize, categorize in different 3 categories. Okay. How to include the modules? Based on the modules we categorize here is going to be different. So the required functionality. The basic functionality of require is to read a JS file and execute it and process return module.export to object. So we'll go through generally talk about it. Then we'll have demos, then we come back, okay? Suppose your module is your built-in module or third-party module, okay? Built-in module and third-party module. When we require, you don't need to have this // thing. Do you remember // when we talk about relative URL? Yes, you just give the module name here. Okay, so when we require, if you like this way, okay, I don't have // thing, then that module is either built-in module or either is a third-party module. And if the module we read by ourselves, then you have to using // Okay, so this part I don't want to explain now because we will talk about some more. Then we come back to category summarize, okay? Because there are some things packaged.json we'll talk about tomorrow, okay? So today I will skip this part. I will come back later. Take a look at it here, guys. Let's take a look at it. Okay. Our first demo, module demo 1. I have another folder. Okay. See here, I have app.js. Okay, and I have another one called hello.js. Okay. So what's gonna happen? In the hello.js file, I just have hello. And in the app.js here, I have just app. So now I will navigate to execute. You will only see app being printed, right? You didn't see the hello being printed, right? The reason is I executed on the app.js and I didn't execute on hello.js. And app.js doesn't have a link with hello.js, right? Now, take a look at this one, okay? Now I just had this line, okay? Now I do Node.js. Can you see here? I have app, I have hello. Now, by doing this line, it links, it also executes the code here. And this require is a part of a common JS module, okay? Now, what is required? Did I have this one here? Can you see here? Require is a global, actually this one is a method, okay? Because we're executing some method, okay? See here, how I use require. Have parentheses. When we see parentheses, that means it's a function, okay? And require is a global function, okay? And you pass what's in the pass to the JS file here, and it will do something, right? Okay, so require is what? Require is a global method. Okay, you can use it in every Node.js file. Okay, so what is require doing? Here, how require do? This hello, even when I do hello or not hello.js or hello, right? It will always looking for. First, you are always looking for something.js file, okay? It can also look for the JSON. We'll talk about it later, okay? You're always looking for JS file. And when you do, so it will look for my JS file, it will do something executed, right? So that is this one talking about path to the file, okay? How require path to the file, either JS file or either JSON file, okay? What it require do? Node will go through the following steps, okay? When we require, it will go through the following steps. First, resolve, which will find the absolute path of the file. Because here we are using relative file, right? All the file eventually gonna store in the file system. So based on the relative file, a relative URL here, he will first find the absolute in order to locate that file in your system, okay? That is this one talking about. Second, we're determining the type of the file content because where it is? Because here, inside the URL here, you can give two types. The first one is a directory. Second one is JS files. If a directory, we are looking for the JSON file, we'll take a look at it later. You got me? The file type, we'll take a look at it later because today we don't cover packet or JSON. Tomorrow we're gonna cover, okay? So here, to determine the type of file, for today, we are only talk about what? JS files, okay? So here, if it's JS files, he will determine if it's a JS file or it's a directory, okay? This is the most important thing, okay? Wrap. To give the file its a private scope. Before the break, I mentioned one sentence here. Node.js was designed to behave differently with everything being local by default. How do they achieve that? It's required doing that. wrap to give the file its private scope. Ask a question. If I execute this piece of code in browser, this I gonna be put in window, right? Okay, but if I use a node, it won't keep into the global object because what? Because node gonna do a wrap. It will give its private scope. So in JavaScript, how can I make this one to be private, not leak to the global? No, hash is private, but hash only works inside the class. We have another thing. How can I make this I not leak to a global? Exactly, Kali. Kali, okay. We talk about function going to create a scope, right? You do you remember? So in this case, I don't have I want to leak to a global. You understand me? And do you remember this thing? Do you remember this thing? If because if we have a function, we have to execute the function, right? But if I wrap in this in the if and this I will immediately execute and it's not linked to a global, right? That is exactly this wrap is doing. Okay, I will see in a minute. Okay, and then it will evaluate, which is we'll take a look at your code and execute. And if it's cached, okay, when required file again, it won't go over. It's gonna cache the result. Okay, so going to resolve, find the path, load, determine the type. If it's a content, if it's a directory, it will looking for packet or JSON. And if a JS file will immediately execute, okay, and wrap it, okay, then this one will evaluate, gonna be executed, okay. Cache means if we require the file again, it won't go over all the steps. It will use a cached value, okay. Let's take a look at how to this step, okay, wrap. How does this step, how do this one, okay? So for all the code we write here, okay? For all the code we write here, when node trying to execute it, it will actually do more than you see, okay? Node will wrap your code into this function. See here. I define function which have exports, require module, we'll see later, okay? And the first line, it will do this line, okay? And eventually, let me explain again, okay? Using the thing, okay? Let me do here. So in my what's thing? In my hello, yeah. Hello.js file, right? I only have one line of code called console.log. I can do another demo too. Okay, wait a minute for a second. Okay. Let me make it extreme. Okay. See here, I have a var I equals 10. Okay. I will have a console.log I. I will have another one. Require. Hello. Here I will define var I equals. You got me? Okay, so here I have var I equals this one. I have another var I equals this one. If in window here I will get a 99. Let me get it 99, right? In window, you gotta understand? Because I redeclare, okay? But when we do like this way, you will get a 10. You see here? You got first you this real 10, right? It didn't using the hello one. But if we execute it in where? If I execute it in browser, you will get what? You will get a 99. No doubt, okay. So how node is 10 is because of require to have a wrapper. Let's take a look at it here, okay. In the hello, I have a var I equals 99, right? Then here we have another one called app.js, okay. Let me make it a little bit further. I have app.js, and then we have this piece of code. You make it larger, okay. You got it? Why this I in hello.js is not exposed in app.js? It's because when we have a require, it will keep everything local. It will have wrapper. How did it? So when Node.js, when I using Node app.js, okay, what's gonna happen? I will execute this one, right? I10. Then I do require, right? Require gonna do what? Oh, you have I equal 99? No, I will make it to be local. How to make it to be local? Do a function, okay? Yeah, sorry, my bad. Yeah. Let me. Okay, wait a minute for a second. Okay, I'll move this one a little bit down. Okay, this one a little bit down. Okay, when we do require, he will wrap all the code inside the function. If inside a function is this I export outside? No, that's why this I is cannot get a 99, it will get a 10. Got me? Because this I is in a function, right? So it's a function will create a scope, right? So it's not. And the second one, ask a question. And when I require, you will see this hello is being executed, right? And if my code is only like this way, will this console log being executed? It won't. Because do you remember our if we have two braces, two parentheses pair, and inside the node he didn't do as if he used apply. What's gonna do is here doing something like this one. Okay. Do you remember apply will make a function call? In if what we did? In if he just do like this way. Okay. And in node he do an apply. He did is using apply to call. Okay. And then later on you can change this keyword. You can add things. Okay. But if we directly using if, you cannot change this keyword. Okay. So the wrap is doing like this way. You create a scope, which is a function, and immediately execute. If I don't have apply, you want to say hello, right? Okay, that's this one. And besides that, you will do something like that. Exports. Okay, and here also have what thing? Which one is first? Requires first. Okay, and we'll have module. And have a DR name and a file name, right? File name first. And have a DRR name. And this also explains in app.js, I use require, right? Why is require? Require is here. I mean, did I declare require? No, why is require? Require is actually here. Okay, and later on, you will see exports, module, and file system DRNM all are populated by node when it trying to execute code require. Okay, and this is a part. And before this line, okay, before this line, he also have another line. Very important, okay? Before execute code, node also add this line implicitly for you, okay? And after all your code in hello.js finish, he also did a return here. So even though in my hello.js, I only have this one line of code, right? You should consider it all wrapped in this all the red things, okay? All the red code, this line, all the code is implicitly executed by node, understand me? And all the function and the apply. Why? Take a look at it here. Did I have anything returned here? No, right? Okay. Let me have something here. This is result of require. You got me? Take a look at it. You see here. Object. This one is because I using this one is string. It will call to string, and let me make it no to string. Okay, you will see something. Because when I link as a string, it will call the toString method. Then by default, the object dot protype toString will give you the string. Do you remember the alert? Okay, so everything is connected. Okay. Hello. See here. What thing? Empty object. So did I return anything here? No. Why you see empty object? Is because implicitly, after I finish your code, right? Our own code, he will return module.exports. Understand? And module.exports is empty object. So don't worry about this one. First, do you understand what it requires doing? To make everything locally. Because why? Because all the code you wrote, it have a wrapper, which a function there. So everything is locally, okay? Now let's take a look at the more, okay? Module.exports, okay? Think about, you have to remember, every module we wrote, at the end, it will return module.exports internally, okay? And you can think about this object as a return statement, as we mentioned here. Let's take a look at it one more time, okay? So here, I don't have anything returned, right? Word. Okay, I will execute the code one more time. Hey, you see word. The reason is what? The reason is implicitly here, JavaScript will return module.exports, right? The default value is empty object. We'll explain one again. But now I did what? I assign word into module.exports. So you are changing what is the value of, you are changing default value, right? So then you get a word. Suppose this one, I change to be 1, 2, 3. Then when you require, you will get 1, 2, 3. This value is 1, 2, 3. So when we require the value get, you always take a look at what thing. Module.exports, that's being returned. Okay. If you don't understand now, don't worry, we'll have more demos. Okay, let's take a look at. Wait for a second, okay. First, module.exports, okay. In our hello.js, module.exports, the default value is what? Empty object, okay. And this line, okay. This one, exports and module.exports, okay. Carefully, okay. What does this line do? What does this line do? This one is talking about, we have argument which is a variable, right? Eventually become a local variable, okay? What does this line do? Not which one? This exports a variable, right? Point to here. Because stack, right? In the stack, we will have lexical environment, right? In a lexical environment, we're gonna have exports, and we're gonna have a module.exports, two variable, right? Two variable, and this empty object eventually gonna be stored in the heap, right? In the heap, right? So at the beginning, modular exports gonna be point to here, which is default value. So what are this line doing? Point to here, right? You got me? Point to here. Got it? That is this line doing. Okay, so here, this is also this line. Exports object is reference to the modular exports. And this, why we use that? When we go to a node in the future, you will see a use case of this one, because every time we use modular exports, you have to type 2 words and have a dot. Exports is shorter, okay? But be careful when we're using exports. If we have some code like this way, eventually gonna have modular exports being returned, okay? This one talking about like this, okay? I will show you this one later, okay? I'll show you this one later. Then let's take a look at how to use modular exports. Then then I will also have this one there too, okay? You're going to see this code in the exam. I'll give you a piece of code, you find out the output, okay? Which are related to modular exports and exports, okay? So let's take a look at it one by one here, okay? Have demo folder and how to use what's the value pattern 1 Apple.js, okay? No, not here, not here. Where's emoji? Wait a minute for a second. Okay, I'll use this one first. Pattern.js, and I also have app.js. Okay, and in my pattern 1, I wrote like this way. Oh, John Smith. Okay, guys, this is my pattern.js, okay? If I require my own module, make sure you use relative URL, okay? So how can I refer to this pattern.js here? /, okay, pattern. You don't need to have a JS file, okay, because Node will automatically add for you, okay? And now I console.log pattern. What's the value? Let's take a look at a pattern, okay? What's the value of pattern? This function, okay? Always remember, eventually after all the code finish, the JavaScript will return what? Node.js will return what? So whenever, what is the modular exports point to? That's gonna become the value being returned. You got me? So I can do what? I can call pattern execute, right? Because a function. You got me? You will see a function, okay? You will see it's a function and it's John Smith. Always remember what's being returned. Modular exports, okay? And what my modular exports like this way, okay? Function, exactly. This is the first thing. You can use whatever you want, okay? Let's take a look at another one, okay? Like here. Let's do second one, okay? Let's print. Take a look at it here. Second example, okay? Apple.js, I'm going to be exactly same, okay? Exactly same, okay? Pattern. Then I'll create a pattern. Take a look at here. Okay. Now I'm root, okay? Yeah. So what's the output of pattern?
Yeah, object.
Empty object?
Object get name.
Yes. Okay, you got it. Okay. You have a get name. Why? It's because what's the thing? Before our code, okay, modular exports is what's the value? Empty object. And when we have object, we have something dot get name equal something. What's it gonna do? It will add it, right? If it already exists, it's gonna do what thing? Update. If it doesn't have, I will just add a property called get name. The value is this function, right? And eventually we'll do what? Return module that exports. You got me? That's why you have not an empty object. You have object. We have which has a get name that. So then we can call what? We can do pattern dot get name. You got me? You can call it, right? Because I use return here, so I have to use what's in console log. Okay. Can go just miss. You must understand. Okay. Because know that this is a fundamental you are used every day. You must understand. Ask you guys another question. What's gonna become the value here? Edward Jack. Why?
It's pointing to the.
Exactly. Exactly. Great. Why? Let's take a look at it. Okay. You must understand. Okay. That's very fundamental in JavaScript called object. What's gonna happen? Okay. So when we do require, I didn't write the function, okay? When we do require, first they will wrap it, right? And first we have a module dot exports, okay? Which will point to an empty object, right? And we said, do you remember this line? Okay, this one will do what? The exports will also point to this empty object, right? So we do, okay, then we execute our code. Modular exports dot get name. Do I have get name? No. If no, I will have a get name added here. The function gonna be return John Smith, right? Then I do this line. Export dot get name. What's it gonna do? Exports what it is. Yeah, this same object, right? And I thought dot get name. Oh, do I have get name? Yes, I have. I will add I do get name. Then I replace this function to this one, right? Well, do a replace another function too, right? That's why you get what's thing. Edward Jack, okay? Did you get this one? You got this one? Okay. What's gonna happen?
Whole thing becomes
I'm going to do what?
a function, okay, not object.
I think.
Monio is correct, okay. John Smith. Let's explain one more time, okay? Okay, let's explain one more time. Think about it. Think about it. Why? Because always return what? Always return module.exports. Okay, let me copy this line. Okay, let me copy this line here. Okay, we set up first, okay. Take a look at here. we have a module dot exports point to an empty object, okay? And then we have an exports, or because of this line, right? Also point to this empty object, right? And all this thing, all those empty objects in the heap, right? Okay, this is in your stack, okay? And now let's take a look at this one. Module export dot get name. I'm gonna have a get name equals function. If you still don't understand this one, you practice by yourself, okay? That's the before midterm exam you have to understand, okay? Which is add a property, and the value can be string, can be array, can be a function, okay, to there. What are this sign doing? When we see equal sign, we have to do this side first, right? This side function we are treated as an object. This is my one object. I have another object, which is a function. What are equal sign doing? To here. Understand? Anything else? No. Then we return module.exports. What is my module exports point to?
Just
Get name John Smith. Understand me? Got it? That's why you see this wrong, okay?
what's this between exports and the module of export?
This exports is a shorthand for modular exports. But if you reassign export to be something else, then you lose the reference to modular exports. You got me? Oh, okay. What's the difference? Don't do like this way, because what's the difference? Okay, let's take a look at the difference. Okay, okay. Modular exports definitely will see John Smith, right? John Smith. Okay. Do you like suppose okay, let's see. Okay. Oh, let's say the first name. How about that? Suppose you have a code, okay, F name, okay. I will do like this. This start the first name. Let's do this start the first name. This is a bad example. F name. Oh, no. I mean, use this here is not a good. Okay. Oh, it's fine. Okay. You got me? I have module exports. Okay. So every time I want to attach a property into this object, I have to use module.exports, module.exports. And another way is, which one is simpler? Exports. That's where I use exports. Okay, but don't do like this way. You know what I mean? Because when you use equal sign exports, you are changing the point to another thing. Then you are lost to the point to the module exports. Because eventually what do we return? We return module.exports. Okay, you got me?
Technically, there are two different variables pointing to the same object.
At the beginning. Yeah, but if you reassign exports, then you are lost to point. So what you use is when you have lots of let me show you an example. Okay. I forgot to put it here. This is another one. When we see later on when we write a node, right, we expose lots of methods. You either use module exports or either use exports for shorthand. You got me? Okay, that's where you use exports. But don't do this line. Because if you do this line, you change to another thing. Eventually, we only return module exports. Okay.
just use it for adding new.
Yes, adding new properties. And if you are not comfortable, always use it module.exports. Okay. Oh, let me go back to that line. Let's see here. Be careful when you use exports. Like if you reassign, okay, then you lost it. Okay. I will ask you another thing. Since we are here, I'll go back to the original one. Equals. Here I'll return. This one is Edward, right? Edward, Jack. Okay. Hey, ask you, do one more thing, okay? What's gonna happen?
So in the return,
It's going to return an empty object, okay? Then empty object don't have a code, gonna have error, okay? See here, because you're gonna have what is? You're gonna have where's my anyway, URC pattern on a get name is not a function because it's empty object, okay? URC empty object, okay? Because here, what all other you create a new object and reassign to it. All others are being losted. Got it? If I give 1, 2, 3, gonna be 1, 2, 3. If I give hello world, so eventually, just remember, eventually what's being returned? Modular exports. You take a look at what's the value of modular exports. That's gonna be final value. Okay. Let's take a look at other examples. Okay. Here has another way to use. Okay. Here. Take a look at here. I commented this one. Okay. What's the pattern now? Yo, I missed something. No. We're gonna have error. No, I forgot this one here. I changed the function. Okay. Got it, son. Then in this case, this one gonna be a function. Okay. Because I use this one is that object, which is get name Edward Jack, right? Then I directly call get name. You got me? Okay. You can use like this way, or you can use like this way. Oh, there's another way. Do you remember destruction assignment? Like this way. Do I see? No, what's the thing? I have get name. Oh yeah. Did I execute it here? Let me see. Okay. That's a function. Okay. And when we execute it, you will get the thing. Okay. Edward Jack. Okay. So it depends on what you want. Okay. You either just grab one thing, destruction assignment, or either grab all the object, or either use dot to grab one thing. It's your choice. Okay. This one, Python 3. This one you want to do in the exam or in your project. This one just show you we do have a cached values. Okay. This one you want to do it. Okay. And it's see, not good practice. That show you here. This is not good. And don't do it. Okay. What does this one mean? Talking about? Okay, let's show me. Okay. Module 3. Yeah. We have to use some afternoon, guys. App.js. And I have what I use here, person.js. Okay, and we will deal with a class, guys. We'll deal with a class. Okay. And I will not use construct function, and you must understand the class syntax. Okay. Please start the last name equals last name. Okay. Let me see here. I'll get a name. Let me use, let's just have console log, because otherwise I have to use console log everywhere I use it. Okay. This dot first name, this dot last name. Okay. And I will do like this way. Module dot exports equals new person John Smith. Don't do like this way. We'll have a better way. Okay. I just show you here. First it's gonna be cache. Second it's gonna be not good. Okay. And then we have another module called the pattern 3JS file. Okay. JS. And here I'm going to do is here I'm going to do is let's first show you here. Okay. Require person. Okay. Did I require person or require pattern 3? Okay. Person, and have a const p equals, because here actually is the person object, right? Which you have a first name and last name, John Smith. Okay. This one you should understand. CD module 3. Okay, node app.js. Okay. I didn't console log. So if I console log p, okay. You will have first name, last name like this, right? Okay. And now I go to exactly same code, go to here. Okay. Oh, when I require here, if I use a pattern.js, you will see the same, because but this app.js, pattern.js is not connected. They are separated, right? So I have to do one more, which is require dot pattern 3. Oh, I have to go there. I have to go here, right? Where I have to use pattern. Okay. Because I have to link these three together. Okay. Where is console log p, pipe.js p? Okay, I should see 2. Okay. Oh, sorry. I have to run app.js, guys. Okay, you will see 2, right? You will see 2, right? Now let's take a look at it here. Okay. Do you see here? Do you see here? This one, when we require, this one is John Smith, right? This one is John Smith, right? Then I change the P to have what's thing? Edward Smith. Right? And in my require pattern, okay? I just did what? I require this from this person, right? We expect what? Here we should have a new John Smith. You understand me? Because here, right side. See here, because in my pattern, which is the last line I doing here, right? The last line. The last time I require pattern, the pattern will require for the person. Okay, person will give me new person John Smith, and I expect here to have what's thing? John Smith, but what I get? Edward Smith. Do you see here? The reason is why? The reason is this line. When we do require, it will have cache. when we require this file again, don't go over steps. It will give a cache. This will prove it will actually go to the cache version. It didn't knew a person, John Smith, right? It will use what thing? It will using this one again. Otherwise, we should see what? 2 John Smith, because I require here again. This one is the first time I require. This one is the second time I require, right? Do you get my point?
And if it calls one JS file, so that will, the whole thing is cached, and whenever it calls again, so it will use it from the cache.
Yes, yes. It's been proved here because here is where I call, right? When I require this one, actually here require again, right? And in my person, I knew a person, John Smith here. And it should give me John Smith here. If it's not cached, you should give me, even though I change here, it should give me the second different one, right? They actually give me the same one because when I require again, it doesn't go over all the steps. It just return the one the first time you require, it will cache that value. It will return this P, not this new person. You got me? Understand?
So, I mean, how does it have a reference to the cache? Because we are giving a module.export as a new object. So because it is going to return the module.export, right?
Because when we require, see here, this statement is same. The right side. This is my first time require. Whenever we require, the first time you require that it's gonna have a kind of like a map to store. The key is required for that person. The value is this one. The second time require, oh, I got the key. I just return the one. I got it. Okay, if you don't understand, we can do this one again, okay. Okay, so we have 3 objects here. What's gonna happen? You can think like this way. This is my person, right? And then we have a pattern. This is my pattern, okay. And the last one is this app.js file. Okay. Let me make a little bit larger for you. This. Make a move to this one, make it a little bit larger. So here, let me name it, okay. So this file is called a person.js, right? And this file is called a pattern.js. And this file is called app.js. Okay. And then what's gonna happen is when I run what? I run node.js, node app.js. Okay. Okay. Then you can think in JavaScript. Oh, sorry, in Node, you have some map there. Okay. Map is key value pair. You understand me? It's a key and this is a value. Okay. You can think I have map there. And so here, when I execute app.js, I will do the first line, which is a const p equals require this person, right? So we'll do the right side, okay? Require. And is this my first time require? Yes, my map is empty. It's my first time, okay? First time require, okay, I go to require, eventually I got this object, right? So what's gonna happen is every time the key you can think is require the person, you got me? It's a key. Then I add the value is what? Value is the first name is John, right? You got me? The last name is what? Last name is Smith. And if this value actually is something stored in a heap, then we point there. You got me? Let me make it extreme, okay? Yeah. We have a heap here. You got me? Heap. And in the heap, we're gonna whatever we knew this object, right? We're gonna have heap have a first name. Yes, what's the thing? John, right? And we have last name is what? Smith, understand me? And this value actually point to this object, right? Point to this object, understand? Okay. So then we console log P. P also we have a variable in the stack which point to this one, which you're gonna see John Smith. Okay, that's why I don't draw it. Okay. Then we change P dot first name Edward. I change this one to be what thing? Edward, because we also have a P point to this one, right? Per this P, okay. Then change to be Edward here, okay. This one point. Now I do require pattern, okay. Now I do require this pattern, right? So do I have pattern? Yes, right? Pattern, oh, it require person again. So in my map, do I have required person? Yes, this one, this is required person, right? And what's the value is point to here, right? So this P now is point to where? Point here too. You got it? This P will point to here too, right? When we console log P, what do we have? First name Edward, last name Smith. That is why I call it cached. Understand?
So that require patterns also be available in the map, right?
This one require person? Yeah, you
That
can.
will also be in the map.
Yes, you're gonna have. I didn't do it. You're gonna have an empty object. Okay. If I require again, it's gonna be a same. That's this one. If you don't know how, if you still don't understand, what you're gonna do? Oh, here have one error. This one should be cached.js. Okay, I'll fix and show you guys upload again. Okay. This one should be this one cached.js. Okay. If you still don't understand, you can ask me in the afternoon. Okay, I have to move on. Don't do like this way. The better way is what? The better way expose the person. The better way is how you do it. This one just show you the cached and the not good one. The better way is what's the thing? I'll have to create another one called module 4. Okay, the better way. Wait a minute for a second. I'll copy paste. Okay, the better way. Person, don't do it like this. Export this person. And then in your app.js and in your pattern.js, whenever you need to have that object, right, create by yourself. This person gonna become a class because I export what's thing. So a person here, okay? Export a person, and whenever you need a person, then you do what? You const p equals new person. Then we do what? John Smith. And later on, you change it to be first name to be Edward. It only change for this P because in my pattern, you still have what thing? This one is a person class. Okay. And I have a const P equals new person and John Smith. Okay. So in this case, even though here I change this P to be Edward, when I require pattern again, you will still get a John Smith because they are different person. Did I have two? Oh, I have a const P here. Okay. Console log P here. You will see this one is Edward, this one is John. Because we export the class, okay, and we create object in each of the JS file, and that is the correct way to do it. Okay, don't export the person. We export the class, and you will see this called often later. Okay. It's about person. Whenever you need a person, create it. Even I require multiple times, you are cached this one, right? Doesn't matter. This one. Last one. Oh, last one you can also do like this way. Okay, last one. The module 5, okay. Let me check. Oh, it have a closure here. Take a look at here, okay. Here I have a pattern.js. I still have a app.js. Okay. And here in a pattern, I have const name equals John. I have a const get name equals function return name. Okay. This name is referred to this name. And don't ignore about this thing because that's the Visual Studio Code, the checker I use. Let me use the first name. Use the username. And you can also do like this way. We can do like this way, right? We can do like this way, right? Got me? Oh, let me make the name to be changed. Okay. Then let me use the app.js file here. Okay, guys, take a look at what's the result of P. If I console log P, what's the result? What? What's the value of P? It's a function?
No.
Did you sleep here?
Object.
Yeah.
Wait. It's used.
What does this one do? You have get a name, get a username, okay? And we choose a function like this, okay? You got me? If I do like this way, it's gonna be a function. Okay. If I do like this way, it's gonna be add a property get a username here. You got me? Got it?
Yeah.
Okay. Node. What's that? CD module 5. Okay. Node app.js. Okay. Get a username. Got me? You for this line of code, you can also write it like this. I did the extreme, okay. You can also do like this way. You can either do this one, but they are different, okay. This one is create another object and which has get your name on it, and this line is extend on this object, okay. Even though the result is same, okay. Wait, my bad. Okay. You are the same, right? Hey, ask the question. If I do like this way, you're going to get a name. It's gonna be function, which is same as this one. Okay, they're exact same. Okay, they're exact same. When I do this line, it's gonna become this line here and this line. They're identical. Okay. So choose the way you like. You either choose this way or either choose this way. You choose. Okay. Any more question? We need to stop here, and we will have the remaining. We can finish today, or we can leave it to tomorrow morning. Okay. Let's discuss later because let me take a look at. We probably finish first. Let's take a look at tomorrow's lecture. How many? Okay. How many slides? 24. 24. Do you want to go over this afternoon or you want to tomorrow morning? Tomorrow morning is fine. We don't have so many left, okay? We can do tomorrow morning, then I will change the assignment to be one day later because the assignment is gonna be related to the remaining one, okay? So in the afternoon, we are going to go over exam. So make sure, okay, for people online. If you are not here, it's better you come to the classroom for the exam, okay, midterm exam. Okay. And the remaining slides we'll leave to tomorrow. We're kind of late. See you. So how about I see you in the afternoon?
Okay.
Okay.